that is now we are having not only the natural radiations, we are having some man-made radiations also, and especially nowadays with the advancements of new medical diagnostic techniques. So those radiations have increased, the level has increased because now we have having so many other medical facilities where we are undergoing so many medical tests for the diagnostic purposes, for which we are exposed to the radiations. So that is the additional thing which we have caused even with the advancement of our medical profession. And another thing, that is the choice of your building materials now have changed. So different type of building materials are now being used during the construction, and that choice is very important, that how to select a building material which gives you lesser amount of radiations. So I will share my ideas with you people, and I will tell you that how it is affecting. Now, a very basic thing which everybody knows as a student, also science student, or even as a layman, that radioactivity was discovered way back in 1896 when Becquerel was working on some uranium salts. Now, what we are interested in, especially as a radiation physicist, that how this bigger nuclei are they are weak, which are not so much stable. They are decaying to form some daughter nuclei and emitting some radiations. So very famous reaction which everybody knows as a fission reaction, uranium fission reaction, where uranium decays to form a barium and krypton, and neutrons and a lot of energies are emitted. So on the basis of this, we have categorized the radiations into different categories. That is, one is the ionizing radiations, another are the non-ionizing radiations. So ionizing radiations, I think you all are aware about the phenomena of ionization, because you all are, what I feel is the science students. So ionization is a phenomena which is basically caused by the charged particles, and they transfer their energies on some of the materials on which they fall, and they ionize them to make the ions. So they are further categorized into the particle radiations and then heavy energy electromagnetic waves. Similarly, non-ionizing radiations, they are low energy electromagnetic waves and ultrasounds. And further, the ionizing radiations are having alpha, beta, gamma, and neutrons. So in our lab, especially at NIT Jalandhar, we are focusing only on the ionizing radiations. We are not working on the non-ionizing radiations, though they are also having a predominantly very big effects on human beings, especially nowadays, where mobile phones are being used and there are a lot of towers are being installed. So in the society, there is a scope for having a study in the non-ionizing radiations, so that you could even people are working for their PhD problems on studying the non-ionizing radiations, that how the mobile phones or how the mobile towers or how the different other things have changed our lifestyle or have affected the human beings. But in our lab, we are focusing only on the ionizing radiations. So where we have categorized the radiations into 4 types, not as a 3 type, which is very common to you, that is alpha, beta, gamma. But I have mentioned it as a 4 type, alpha, beta, gamma, and neutrons. Though neutrons are not directly radioactive in nature, but what happens that once the neutrons strike some of the materials, they allow alpha, beta, and gamma to come out. And this picture will give you an idea that how it is being utilized in terms of stopping power. So alphas can be stopped by a thin sheet of papers, betas could be stopped by a thin sheet of metals, and gammas or X-rays could be stopped by thick lead sheets, and even neutrons. For neutrons, you have to use concrete or heavy water, so which is very commonly used in nuclear reactors also. So though neutrons are not directly radioactive in nature, but once they fall, they allow alpha, beta, and gamma to come out. So that is why we have made 4 categorizations instead of 3. And there is a very basic question, especially uh, from the students, they should know what is the difference between X-rays and gamma rays. So they looks very similar, even in terms of energy, even in terms of their effects on the body. But the basic difference, which every science student should know, is the origin difference. That X-rays, they are originated from the electrons, or the electrons revolving and gammas, they are originated from the nucleus transitions. So they are originated from the inside the nucleus, and X-rays, they are originated from the nucleus across the orbits or electron orbits which are there. Now, it is everywhere. So natural radiations, we generally say it is everywhere, because natural radiations, they are coming from the sun in terms of cosmic rays. They are even coming from the soil. They are even coming from the plants. They are coming from the building materials which you are using. So I've already told you that the choice of building material is also very important in terms of radioactivity. If you are really interested in measuring the exact value of radioactivities. Now, these are the sources of radiations which we have categorized in terms of the total combination of 100%, where natural radiations contribute to 82%, and the man-made radiations contribute to the 18% category. And out of this natural source, 55% contribution is only due to one element, that is radon. So that is why the study of radon is very important. The reason being, if you study radon, you could have a assess about the total 55% contribution due to one source itself. So, and secondly, radon, why it is important? Because radon is a gas. So once a thing is in a gaseous state, so it is very difficult that you could escape from that gas, because it will be present everywhere. If you are sitting in a room, if you are moving outside, everywhere in the air, you will be under the influence of radon. So if you inhale something, so just in terms of inhaling factor, if you say if you inhale more air, so what will happen if radon concentration is more in the air? So more radon will enter to your lungs. So मैं जनरली अपने बच्चों को हंसता होता हूँ कि बाबा रामदेव से इसकी लंबे लंबे सांस लो, तो लंबे लंबे सांस लोगे तो ज्यादा रेडॉन अंदर जाएगी. If it is influenced by the radon, if radon is present in more values in the environment, so the radon जब अंदर जाएगी, so it has its own natural half life of 3.7 days, and once it decays to form polonium. So it emits one alpha particle and decays to form a polonium 218. Radon has an atomic weight of 222, and then it decays to form 218, that is polonium, and then which further decays to form polonium 214. Now, those alphas, you have seen from this slide that alphas can be stored by a thin sheet of paper, but once you have inhaled those alpha sources, so what is happening that those alphas which are decaying from the radon, they are affecting your internal lining of lungs. Because अगर वो बाहर से अंदर नहीं जा सकते, तो अंदर से बाहर भी नहीं आ सकते. So that is why if alpha is being generated, once you inhale some alpha emitters, so that alpha will be generated within your lungs, and that alpha will be giving its energy to internal lining of your lungs, so which can cause damage to internal linings, and which can cause damage to your internal lung structure, and which is the large after cigarette smoking for the lung cancer. So that is why radon is known as the second largest contributor for lung cancer after the cigarette smoking. Now, once we study radioactivity, sometimes it is being asked that we have to measure radioactivity in terms of different units. Now, this pictorial representation will give you an idea that why those different units are required. Uh, I have made a figure which will give you a very clear-cut idea that if you are just measuring the number of disintegrations per second, that is the natural radioactivity, we generally measure it in terms of a unit which is called becquerel. So that is the number of apple fallings from a tree, just for a pictorial representation. And suppose a person comes and had a nap beneath that tree. So what will happen? So whole of the apple which are falling from the tree, that will not strike that man. Only few apples will strike that man. So only those few apples which are striking that man, that can cause radioactive effect on that man. So that is why there is another dose, absorbed dose unit, which is called gray. So we are having a different unit that is gray, that is absorbed dose. Now, after this absorbed dose, so whatever I have absorbed, so what will be the effect on my body? That is my effective dose. So this I have shown with the picture that a hump is created. Of course, with the apple, no hump could be created, but just for a pictorial representation, that apple falls on the head of a person and a hump is created. That is the effect on the body. And you will be surprised to note it down that our lab is the only lab in northern India or even in India who are working on the biokinetic modeling. So we are calculating the gonadal doses, like for the natural uranium content in water, we are calculating the per organ doses, like how much effect for that particular content of uranium in water will affect your kidney, how much effect will be there on your lungs, how much effect will be there on your bones, how much effects will be there on your other tissues, maybe of legs, maybe of hands, maybe of your brain. So per gonadal doses we are calculating with the help of ICRP model, biokinetic modeling. So our publications in that areas are highly recognized by the people who are working in the medical radiation physics, because then you can have an estimation of the effect on the different organs, and you as a medical physicist could decide in terms of treatment of a person for the medical diagnostics that that particular portion is already having this much of effect, so whether we should go for this type of a medical treatment or not. So that is why this study is very important. Now this is actually the impact of exposure I have shown you with the help of a just one table where you could have an idea that if your exposure is in terms of 50 to 100 millisievert, so it could change your blood chemistry. And if the exposure reaches to a level of 500, it could cause you nausea. Nausea means severe cold, you could say. And effects will be measured within hours. But if your dose reaches to of the order of say 750 millisieverts, within 2 3 weeks the effects could be there, and you could have hair loss, you could have vomiting, you could have fatigue, and if it further reaches, you could be suffering from diarrhea, then blood loss, and within 2 months, if it reaches to 400 or 4000 level, a death could occur. And again, to a very high values which have been mentioned in the table. But to your surprise, I would like to share with you people that this 50 millisievert is a very big dose. Generally, on an average, we are having a annual receptive dose of natural radiation is of the order of 1.2 or 1.3 millisieverts, of the order of 1.2 to 1.3 millisieverts. Of the total contribution of around 2 point something, 2.5 or 2.6 millisievert per year. Only 1.2 or 1.3 millisieverts is contributed by the radon itself, means 55% contribution. So 50 is a very high level, and in the nuclear accidents, those doses could be received. There were only two famous nuclear accidents which are known to every mankind. One was the Chernobyl in Russia, and another was very recent, you could say, in Fukushima in Japan, where due to the tsunami that Fukushima power plant was destroyed. But still, the dose at a particular instant of time was not more than 10 milliseconds. So you could imagine that how safe the nuclear reactors are. So even in the case of accident, the maximum dose was very much within the controllable limits, not permissible limits. There are some terms which are called permissible. There are some terms which are called controllable limits. So it was still in a controllable limits. Now, why we study radiations? Of course, now you could answer these questions because I have already discussed that radon is a gas. So once thing is in a gaseous state, it becomes uncontrollable. Similarly, nuclear power, weapon testing emits radiations. Radiation causes damage to our cells. I've already explained you. If one alpha is there, you can stop at your body with your shirt. If you are wearing that, alpha will not affect your body. But if you inhale that alpha, it can damage your internal life. So radiations are invisible and are only detected by the detectors. So their effects are seen after few years of inhalation. They are not very much instantaneous. Of course, if you give a very high dose, like in terms of chemotherapy, so of the order of 700 to 800 millisievert dose is being given to the patients, then effects could be measured within 21 days or 4 weeks. And you have seen that once a person has undergone a chemotherapy treatment, so that person is having a hair loss after first or two cycles maximum. Third cycle से पहले पहले उसके बाल झड़ जाते हैं. So that is why, because we have been exposed to a very high level of radiation use. So then again, its study is very important because it estimates the health risk associated with the average indoor radon level, so which is very higher in case of carcinogens, and lung cancer, skin cancer, kidney disease, and other health effects are attributed for the inhalation of radon decay products. So that is the reason why we study radiations. But one thing is very important, that you should always remember that to study radiation is not to make you people जिसको हम बोलते हैं ना, एक हवा सा क्रिएट कर देना कि पता नहीं क्या हो गया, स्पेशली इन मालवा रीजन. बट my request is, there is a lot of hue and cry in the last few years that the water in the Malwa region is very high level of uranium contamination, so people will die. It was known as even cancer belt. Even some pictures were produced in that area. So no doubt it is having a little bit higher value as compared to the other regions of Punjab, especially the Mansa belt, or even Burj Hariki areas are there in some of the Mansa district, where the levels are very high. But still, the levels are within the permissible limits, that it can be controlled. It can be controlled. And the only thing is the awareness, which is required by the people, that what type of building materials they should use, or what type of ventilation conditions they should use, so that they would have a lesser exposure. Because it is very important to have a choice of the building materials also. Suppose if you are using granites in your houses, so we know as a physicist, even as a geologist, even as a person who is working in the fields of studies of rocks samples, he or she can very easily tell you that granites are, or they are naturally radioactive, because granitic rocks are generally found which are having high concentrations of uranium. So more and more use of granite will definitely have more and more use of radiation accumulation in your houses. And nowadays, we are having different types of construction. Like even our kitchens are having very less ventilations. We are having closed kitchens. we use the chimney only, don't prefer to have a window in the kitchen, and we rather don't open those windows. So glass की partition से हम लोग बना लेते हैं, but where the ventilations are poor, there the chances are more that you could have a more trapment of that radiations which have been emitting from the different building materials. So that is why it is important to have good ventilation conditions. Also, it is important to have a good choice of the materials. Even a black granite, which is naturally radioactive, is having more concentration of uranium contamination as compared to the white granites. So sometimes you and architects, even the doctors, the physicians or the radiologists have to sit together so that you could decide. Suppose you are giving a treatment to a person, so who has been exposed to CT scans or PET scans or another medical diagnostic things. So there, that patient will be exposed to the radiations. So because those medical diagnostic techniques are using some radioactive material. So the nutshell accumulation throughout a year should not be more than the permissible limits. So, but in India, we don't have a rather a rule or policy also. Like if one has undergone X-ray or one has undergone a CT scan or a PET scan, the doctor should give him or her a certificate that you have been exposed to this much of radiation. But in Germany, in especially European countries, it is mandatory for the physician or especially radiologist to certify that this much of exposure has been done to you. It is very important because that patient should know that I have been exposed to this much of radiations and now my annual accumulation will be affecting it. So that is why doctors don't prefer to go for a CT more than thrice for a pregnant lady during a pregnancy cycle. Because every time that fetus is exposed to radiation, so it can damage or it can have some effects on the fetus itself. So that is why they have not been allowed to go for a more than thrice. But sometimes for the medical complications, they have to perform diagnostics. So it could affect. So that is why it's a study is very important. Now, these are the few studies for the references which have been given in newspapers and different studies that lung cancer, skin cancer, and kidney disease are caused due to the inhalation. And similarly, in the Bathinda and Malwa region, some of the studies have been conducted, which is causing cancers. But still, it is in the controllable limits. Now, this is a very important study which our institute have conducted, where we have said that even the cement containing fly ash, there is a problem in India now. We are an energy producing state which is totally dependent upon the coal energy. And hydro is a very less, but most of the time we are a thermal based. So in the thermal power plants, what is happening that the residue of the coal, that is fly ash, that is a big problem for the government. Where to dump it? Now, what we have seen that government has made it mandatory. Whatever the cement you are getting from the market, that is a PPC cement now. You can't get an OPC, ordinary Portland cement. You can't get. Only CPWD or building and road organizations could get that direct from the cement companies. But otherwise, for commercial use, for your purposes, for construction of your houses, you can only get the PPC. And it is mandatory by the government that for the PPC, there should be a mixing of fly ash up to the level of even 35%. So, what 65% cement and 35% fly ash. No doubt, as a civil engineer, if I would say it has increased the binding capacity of the cement. We have done so many tests with our civil engineering department also. The binding capacity increases once we increase the concentration from 15 to say 45% of fly ash. within the 100% of cement. But on the other hand, the radiations also increases because fly ash is naturally radioactive because the coal which you are cutting, especially in our areas in Punjab where the Lehra Gaga, even the Ropar, even it was there in the Bathinda or Talwandi Sabo thermal power station. The coal which we are getting, they were coming from the Singhbhum areas most of the time. And that is very close to some mine areas which are having uranium contaminations. So Jaduguda is there in that area. So it is having a natural radioactive inbuilt in it. So once you use that fly ash as a cement, so your walls which are being plastered by with those cements, so they are emitting those radiation level. And to your surprise, we have done a study by name. We have not done it with the sample ABC. We have done it with the help of JK, JP, Shri Ultra, JK, Lakshmi, Binani. So all big giants of the cement, and my director has to face a court case for this also. But to your surprise, ultimately they have to pay us a compensation of around 3 lakh each by all these five companies and give a research project to us so that we could do work that how that fly ash, that is what is the actual limit that should be set for the fly ash so that the radiation level doesn't exceed the permissible limits. Similarly, ROs which have been installed, especially in your areas, in the Malwa regions, if some of the students belong to the rural areas, you could see that government has done a very big initiative to install ROs of the capacity of 1200 liters per minute. Even with the not per minute, per hour, sorry. मतलब एक घंटे में 1200 लीटर पानी वो filter out कर देते हैं. But to your surprise, what is happening actually that what they are doing, they have installed an RO. I have personally visited those areas where those ROs have been installed along with the Deputy Commissioner of Mansa and Deputy Commissioner of Bathinda. And what they are doing actually, RO has a 50% nearly wastage. तो उसका जो रेजिड्यू आता है वो बाहर निकाल देते हैं हम लोग. अपने घरों में भी लगाया होगा, देखा होगा. No doubt RO is removing some of the contamination of some heavy metals and even some percentage of uranium. But that residue, they are allowing that residue water to flow into the fields which are used for cattle feed. Now what is happening? आपने 100 लीटर 1 लीटर पानी लिया, मैं जस्ट एग्जांपल बताता हूँ. 1 लीटर पानी लिया, उसमें अगर 10 ग्राम कोई हैवी मेटल था, अब उसकी कंसंट्रेशन थी 10 डिवाइडेड बाय 100, मतलब 10 डिवाइडेड बाय 1000, तो 10 ग्राम बटा 1000 मिलीलीटर. अब आपने 500 ml उसमें से साफ पानी निकाल लिया, which the government claims कि RO से हमने निकाल दिया. ओके, आई पर्सनली एक्सेप्टेड कि काफी चेंज हो गया, कुछ हैवी मेटल रिमूव हो गया. नाउ वो जो बाकी 10 ग्राम, 10 में से 8 निकल गया, चलो 2 ग्राम आ गया 500 ml में, और जो बाकी 500 ml वेस्ट किया उसमें वो 8 ग्राम चला गया. ठीक है. अब वो 8 ग्राम हैवी मेटल 500 ml में है, पहले वो 10 ग्राम हैवी मेटल 1000 ml में था. अब वो ये बताओ कि जो वेस्ट किया मटेरियल उसमें कंसेंट्रेशन बढ़ गई. मींस previously it was 10 divided by 1000, now it is 8 divided by 5000, which is higher as compared to 10 divided by 1000. Now they are allowing that water to enter into the fields where the cattle feed is being grown. अब वो कैटल फीड जो पट्ठे हैं वो खा के गाय दूध दे रही है, और वो दूध हम पी रहे हैं, और वो दूध के थ्रू हमें कंटेमिनेशन दोबारा वापस आ रहा है. सो ऑन द फूड साइकिल इफ यू स्टडी, सो योर डायरेक्ट इनटेक हैज it has not directly decreased. So you people are working in an area where you are reducing something and then from the other source you are increasing that value. सो वो गाय को भी बीमार कर रही है, गाय के दूध से हमें भी आ रहा है, और दूध में रेडिएशन लेवल बढ़ रहा है, वो कंटेमिनेशन लेवल बढ़ रहा है, और जिसको हम पी के और बीमार हो रहे हैं। अब वो प्रॉब्लम क्या आ गई कि प्रॉब्लम ये आ गई कि we as a chemical scientist should work on some of the processes where this RO's wastage should be reduced, and that wastage should be done in such a fashion that it should be removed from the waste material also, wastewater also. So that is why NGT has taken a very strict action now. They have asked all the deputy commissioners to remove all the ROs. ROs are now, they have not been recommended by the National Green Tribunal because इससे पानी की वेस्टेज भी ज्यादा हो रही थी, कंटामिनेशन भी ज्यादा हो रही है. Now we are working on some of the polymers where we are developing some of the even natural polymers that if you allow that water to filter out of that polymer, it will be absorbed within the polymer, and then that polymer layer is being removed, and your filtered water, which is having lesser contamination, that is allowed to be distributed among the public. But there is a problem also. हमने कई फिल्टर्स ट्राई किए, डॉक्टर कायंत और मैं एक काम भी कर रहे हैं हमारे डिपार्टमेंट ऑफ केमिस्ट्री में. वो पॉलीमर पहले तो अब्जॉर्ब करता है, लेकिन 10 मिनट बाद वो पॉलीमर फिल्टर डी अब्जॉर्प्शन शुरू कर देता है. तो 10 मिनट तक तो जो पानी आता है वो बहुत अच्छा आ रहा है, लेकिन 10 मिनट के बाद वो डी अब्जॉर्प्शन हो रही है, तो वो पानी फिर कंटेमिनेटेड हो रहा है. But still we are working because it is a continuous process, continuous research on which we have to work together, especially with the chemistry people as well as with the chemical people. Now there are few agencies who are working in this area, that is ICRP, IAEA, that is International Atomic Energy Agency, IARP, Indian Association of Radiation Protection, Bare Biological Effects of Ionizing Radiation, and ANSCARE. So those are the agencies. Even WHO is there also, who are working in these areas, and they are deciding different permissible limits for air, water, and soil, that what should be the contamination limits. So what we are interested, we are focusing on the radon in air, radon in water, radon in soil, uranium in water, uranium in soil, radium, potassium, and thorium in soil. So these are the few things which we are working as a radiation physicist, and you people can always have an idea or join our lab to do some small projects, that you can bring some water samples from your area, and you could have an assessment that what is the uranium contamination level, and if this much of contamination level is there, what will be the effect on our body. So you could always studies. Then the important techniques which you could use to measure, of course, we won't go into the detail in this webinar, that what are all the techniques, but you could always note down that for radon and thoron in air, you could use SSNTD, that is solid state nuclear track detectors, where you could use pinhole cup dosimeters. Then one sensor is DTPS, that is direct thoron progeny sensor. Progeny means daughter product. Another is DRPS, the direct radon progeny sensors, and another is RAD7. We all are having these detectors in our lab. Then uranium in soil could be measured with the technique, fission track registration technique, gamma ray spectroscopy technique. Similarly, uranium in water could be measured with your fission track registration technique, laser fluorimetry, LED fluorimetry, ICP-MS, that is induced coupled plasma mass spectroscopy. Dr. Duggal has worked on these areas, uranium contamination in water. So radium, thorium, and potassium in soil, you could use gamma ray spectroscopy techniques, where you could measure the radium, thorium, and potassium in soil. So these are the few radioactive materials which we are interested, which are naturally available in air, water, and soil. That is radon, thoron, uranium, and radium, thorium, and potassium in soil. So we are working in these areas. So I would like to share with you this decay series, not all the detailed techniques. If you see this decay series, where alpha decay has been defined with the mauve color. नजर आ रहा है सर, कलर नजर आ रहा है?
Yes,
So beta is with the mauve color, alpha is with the blue color, and gamma is with the little bit reddish or orange color we have defined. And there is always a trend. As a physicist, there is always a trend that if an alpha decay is there, it will be towards the left and downward side, because atomic weight and mass, because helium is being emitted out, so atomic number will reduce to 2 and atomic mass will reduce by 4. So this is a nomenclature how to write or mention in the series, which as a physicist you should always follow. And if it is a beta, it will go upward. So ये ऐसे नहीं कि इसको नीचे कर दिया, ये स्टैंडर्ड नॉमेनक्लेचर है कि इसको नीचे करना, इसको ऊपर करना. जब गामा है तो गामा में कोई मास चेंज नहीं हो रहा, so gammas are only emitted out. And these are the two important series, because thorium, world's 97% thorium is present in India. And that is why our president, ex-president, Dr. APJ Abdul Kalam, was always giving a stress that we should go for a thorium-based reactors. Because world's 97% thorium is available in India instead of uranium-based nuclear reactors. And but we are not having surprisingly, we are not having a technique to extract that thorium from our natural soil and use it as a source for our nuclear reactors. That enrichment technique is not available with us. We are dependent upon the USSR, USA, and even France for that enrichment contribution, and they give us a source to us. Now, if you see this series, out of this series, once a decay occurs, we are having an element called radon. Now, radon further decays to form two daughter products in which we are interested, that is polonium and polonium-214. Now, these two daughter products are very important in terms of study of radon. The reason is, by studying the daughter, you could always have because we know that this much of a decay has occurred, this is the lambda for this radioactive element, and we can always calculate the concentration of a parent from the estimation of daughters. So we could calculate the contribution of the radon. So that is why the study of radon, as it is a gaseous state, and then its progeny, that is polonium-214 and 218, is very important. Just for a choice of measurement, that how we should go for the measurement, we should go for either long-term measurements or we should go for our short-term measurements. And that depends our choice, because if we are interested in having an exact value, then we should always go for long-term measurements. Means we should deploy our detectors for long-term, for say 90 days or 100 days. But if we are interested in only having instantaneous value, we should go for a short-term measurements. So there are some detectors which are doing short-term measurements. There are some detectors which are doing long-term measurements. The choice depends upon us, that what type of estimation we want to have. And of course, some advantages and disadvantages I have discussed, that if you just want to have a preliminary indicator, you should always go for short-term measurement. It will give you quick results. But disadvantages, you cannot have an effect of the seasons, you cannot have effect of the ventilation conditions, and you cannot calculate the true value. Because I have already told you by showing that picture of a tree and a person sitting beneath the tree, that suppose there are some concentrations are there in your area. So how much time I will spend in your area, that is my dose. So how much time you will be spending in that area, that is your dose. So if you go for a long-term measurements, So you will get a clear-cut idea that within the variation of season, how much effect has taken place. That is why preferably you should go for long-term measurements. And the most important detector for the long-term measurements, which we generally use, is the single pinhole cup dosimeter. I will show you the detector, not going into the detail. These are the detectors which we deploy for the measurement. And this is actually, you could see that this is a detector. जो previous detector, ये black से जो रिंग है ये खुल जाते हैं, पेज है ये basically. तो ये इस तरह का detector होता है where we allow the air to enter from these pinhole and then enters to a first compartment which we call as a radon plus thoron compartment. There is a detector. ये detector cellulose nitrate detector है, which we call as LR115. It is having a sensitivity of the order of 4.7 MeV, that is of the order of 4 to 5 MeV. Now, if any alpha which is being emitted out from the parent having an energy of the order of 5 MeV or 4.5 MeV, this detector will sense that alpha. And that alpha will strike this detector and will create a track, अपना एक रास्ता छोड़ जाएगा. So purpose is very simple. On the second, this is second compartment which we call as a radon compartment, because जब radon और thoron यहाँ से enter होती है, thoron का half life 55 seconds है, तो 55 seconds में वो खत्म हो जाती है और जैसे जैसे ये ट्रैप करती है तो वो निकल जाती है. तो सारा यहाँ पे radon और thoron होता है. यहाँ पे जो 4 holes हैं, they allow only radon to pass through this chamber. So this chamber consists of radon itself. So now this radon. So we are having a total effect of radon plus thoron. Then we, from this detector, we could have an effect of radon only. And then by subtracting that effect, we could have an effect of thoron. Now, purpose is very simple. जैसे मैंने बताया, it's sensitive for energy of the order of 4.7 MeV. Now, once that alpha from the polonium, which is of the order of say 7 or 6 MeV, which strike this material, as it passes, its energy reduces and comes to the detection limit. So it creates a track. So हम इसको remove करते हैं after few days, and then we use some equilibrium factors. Just for your knowledge sake, it's not exact factor, but if it is one track per centimeter square per day, हमने 90 दिन लगाया, हमें per centimeter square idea पता है कितना है detector का size. So one track per centimeter square per day will give you radon concentration of the order of 50 becquerel per meter cube. So 50 becquerel per meter cube. तो हमें number of tracks पता होता है, हमें number of days पता होता है, हमें size of detector पता होता है, so we could easily calculate the concentration. This is just an example. It is not exactly 50. Now we have modified the factors. So by just studying, just for your knowledge sake, that how we study, we allow this air to enter it chamber. और वो इसको hang कैसे करते हैं वो मैं आपको दिखा देता हूँ. This is how these are being hanged. So we are hanging these detectors in the houses in such a fashion that it should be away from your ceiling. It should be away from your walls also, because direct building material का effect ना आए. Only जो air that is surrounding this detector, that should. This is the mesh जहाँ से ये air enter करेगी. जो नीचे वाला चैम्बर था. नीचे वाला चैम्बर. So, यहाँ से enter करेगी. This compartment is radon plus thoron, and then this detector is there. This is detector. This detector is cellulose nitrate, just for your information. So this is how they are being handled. So with this, these are the few instruments which are available in our labs. You could always use facilities of these instruments, and then whatever, I think uranium and water, little bit I would give you an idea that there are some agencies who have given a different contributions. That what is the permissible limits of uranium contamination in water from WHO and US EPA, United States Environmental Protection Agency. That limit is fixed as 30 microgram per liter. And for Indian biological system and environment, that limit is fixed as a 60 microgram per liter. Microgram per liter means ppb, parts per billion. So you could always have a choice of contamination, that if my water is having more than 60 ppb, that is microgram per liter, it is beyond the permissible limit recommended by the ERB. There is a need for a treatment and solution of that contamination level. So for Indian environment, it is 60. As far as WHO is there, it is 30. With this, I give a stoppage to my talk, and any questions, if it is there, you are welcome.
Thank you, Dr. Saab. So, sir, I have one question before taking the questions from the chat box.
Yeah.
First of all, the detectors you have discussed in the lecture about the deployment of detectors in your houses, the dosimetry cup. Sir, would you tell where is the availability of these cups so that we can
pinhole cup dosimeters are available with a certified agency of the BRC, that is a root creator. It's available in Bombay. I could share the address with you people. It's around 1,000 rupee cost is there for this cup. And because cup is not only important thing, you could take those cups from we people also as a pilot study if you want to really deploy those cups. The most important thing is the cellulose nitrate detector. Because that detector is little bit costly. So that detector of the thick size of 2.5 to 2.5 centimeter generally cost you around 3,000 rupees. Because that film is very costly. One packet costs you around 25,000 rupees. There is a big roll which comes around for a 70,000 rupees. And if for pilot studies you are really interested, we can share our detectors and pinhole cup dosimeters. You need not to purchase it from the market, but otherwise you could always purchase if you are having a funding. So that cup's cost is around 1,000 rupees excluding GST, and then detector will cost you around 3,000 rupees for two detectors of this much of size. So because you will be buying the films which consist of 25 films, and that packet is around costing you 30,000. That you could purchase from the Kodak Pathé, who are having their direct suppliers in India, that is environmental consultant. Even Poltech is supplying from the Bombay. So Kodak Pathé is manufacturing this type of film, LR115. That is a cellulose nitrate basically.
Thank you, sir. Thank you. So one more question मेरे mind में आ रहा है कि you have discussed about the permissible limit of this radiations as per World Health Organization or our Indian agencies. There is very long range from 1.9 to 60.
1.9 to 60, because 1.9 is by the ICRP, which is basically for the radiation workers. Now, why there is a very less limit 1.9? Because the radiation workers has already taken care of so many things. They are having radiation safety measurements. So once they are using this, that is why, because they have been already exposed to some of the other radiations who are working in radiation area. So for if they will drink a water containing more than 1.9 ppb, so it will add up to their natural dose, which is already coming to them due to their occupational exposure. Because radiation workers are generally working in those areas, especially in mine fields. So where the uranium mines, if you are working, you are directly having an exposure. So for your case, the water contamination should be lesser, so that the nutshell effect on your body for the annual exposure, it should be less. But Indian environment, generally our biological structure or gonadal structure, the body structure is such that we could bear more doses, and it's a good thing that ERB has suggested that, of course, 60 is the permissible limit for us as against the WHO's recommended value of 30. But there are some political factors also. There are some political factors also which I couldn't share on this platform, because otherwise it will create a hue and cry. So if suppose in your area, if you develop a study and you publish that study, first of all the sarpanch will go to the DC कि ये क्या लिख दिया आपके बंदे ने, तो हमारे लोग तो डर के मारे मर जाएंगे. So sometimes we don't want to create hue and cry also. So हम 1-2 साल कॉम्प्रोमाइज कर लेते हैं कि चलो उसकी हेल्थ का थोड़ा सा इफेक्ट हो रहा है, बट नो डाउट क्वेश्चन इज वेरी जेन्युइन. If WHO has recommended 30, why ERB is suggesting 60? But there are some areas in India where the levels are a little bit on a higher side. So just to avoid those hue and cry, and we suggest that those people should not be exposed to other artificial radiations. So we have increased the limit to this value.
सर वन मोर क्वेश्चन, यहाँ पर बठिंडा में वो जो पंजाब गवर्नमेंट ने ना आरओ सिस्टम लगाए हुए हैं हर एक जगह पर, हर एक मोहल्ले में लगे हुए हैं.
मैंने देखे सर, मैंने डिस्कस किए थे ना आपसे, वही तो मैंने किए हैं कि वो उसका कोई फायदा नहीं है सर. मैं फ्रैंकली हर प्लेटफॉर्म पे ये कहता हूँ, दोज आरओज आर जस्ट वेस्टेज ऑफ मनी, एंड गवर्नमेंट हैज मेक बेफूल्ड ऑफ ऑल द पीपल, और बेड़ा गर्क कर दिया इन्होंने. और वो आपने आरओ देखा होगा गांव में जो 50% वेस्टेज है वो पट्ठों के थ्रू हमें फिर वापस आ रही है, उसके ऊपर कोई काम नहीं कर रही है. ये जो चीफ इंजीनियर्स हैं वो पॉलिटिकली बाउंड होते हैं ये काम करने के लिए. इवन एनजीटी ने मना कर दिया सर, अब तो आरओ अब सारे रिमूव हो रहे हैं. इवन इन जलंधर आपने देखो, मैं इतने सालों से रेडिएशन में काम कर रहा हूँ, आई हैव नॉट इंस्टॉल्ड आरओ इन माय हाउस. जो आपका 150-200 लेवल है हमें बॉडी के लिए चाहिए मिनिमम TDS लेवल, वो भी नहीं हमें मिल रहा, क्योंकि इसकी सेटिंग जो करने आते हैं वो इंजीनियर्स नहीं है, वो एक लोकल 10वीं पास 12वीं पास बंदे रखे हुए हैं कंपनियों ने. और अब क्या हो रहा है, आप पहले कॉपर रिमूव कर रहे हो, अब कॉपर वाला टैंक लगा के कॉपर इंड्यूस कर रहे हो. तो इससे तो बेटर ये होता है आप चांदी का गिलास रात को भर के रखो और सुबह वो पानी पियो, तो आपको एक अच्छा साल्ट कंटेंट जाएगा. तो ये आरओ कंपनियां बेवकूफ बना रही हैं सर इसको. बाकी ये मेरा पर्सनल व्यू है, बट इसमें साइंटिफिक स्टडीज मेरे पास इन्वॉल्व हैं. सो वेयर देयर इज सिंपली अ वेस्टेज. So that is why we have published this study in the Tribune. It's the national newspaper, and it was published in their national edition. So that is why hue and cry was there in the government of Punjab also. आज की डेट में भी सर हमें जब तक हम न्यूक्लियर के ऊपर शिफ्ट नहीं करेंगे तो हमारी जो ये प्रॉब्लम है ये बढ़ती रहेगी, बिकॉज फ्लाई ऐश एक बहुत मेजर प्रॉब्लम है जो हम लोग अभी फील नहीं कर रहे, लेकिन बठिंडा वाले लोगों ने कईयों ने फील करना शुरू कर दिया, स्पेशली सम ऑफ द एरियाज वेयर फ्लाई ऐश डंप हैज बीन क्रिएटेड एंड नाउ कॉलोनीज हैव बीन. वो गुनियाना रोड पे आप देखे आगे कॉलोनीज बन गई हैं जहां पे डंप के ऊपर ही there are medical problems.
Sir, there are some questions in the chat box also. One question is from Ankita. Sir, when we boil drinking water up to 100 and then let it cool down, then can we say that yes, even radioactivity elements may have been decreased due to amount of energy they have given during boiling?
बॉइलिंग से सर इवन आरओ से भी सर यूरेनियम कंटामिनेशन रिमूव नहीं हो सकती. आरओ से या बॉइलिंग से आप हैवी मेटल्स को कुछ को सेटल डाउन कर सकते हो, स्पेशली जो सल्फर है और फ्लोराइड है वो सेटल डाउन हो जाता है. अगर आप स्पेशली आप बठिंडा और मानसा रीजन की अगर बात करें तो यहाँ पे शोरे की प्रॉब्लम जिसको हम बोलते हैं वो बहुत ज्यादा है. तो वो थोड़ी देर बाद वैसे ही सेटल डाउन हो जाता है। बॉयल करके आप फिल्टर आउट कर लोगे तो आपका बर्तन वो आपने देखा सफेद सफेद सा हो जाता है चारों तरफ से। तो वो कुछ वैल्यू कम हो जाती है, उसमें कोई डाउट नहीं है। दैट इज द बेस्ट वे टू ड्रिंक वाटर।
Okay, sir. One more question is from Ankita. Tell how can we enter into medical physics after doing PhD in experimental atomic and radiations?
देखो, for medical physics, what I would suggest you that you should enter without PhD, because there is a radiation diploma, medical physics radiation diploma, which is conducted by the BRC, that is 100% placement oriented, and only conducting that diploma. And after PG, you could join that diploma, BRC. And even 7 to 8 students of our last to last year batch were selected in that. Now they are working as a radiation physicist in some of the reputed hospitals. So you need not to go for the PhD. You could join that radiation physics diploma after your PG, after MSc physics.
One question is from Raman Kumar Mishra. Is bisphenol cause cancer?
How? Raman
This
Kumar Mishra.
bisphenol A.
1152.
So I don't have an idea because I am not working in this BPA. But the other question which he has asked, that how accurate is the air things radon detector? The accuracy rate is of the order of 97 to 98%, and these detectors have been calibrated with a lot of experimentation which has been done, and just for the purpose of defining equilibrium factor, people have spent their PhD for only defining just the equilibrium factor. Like I was saying, 1 track per centimeter square per day is equals to 50 becquerel per second. ये लिमिट निकालने के लिए 2-4 PhD हो गई. So accuracy में there is no problem. That is 90 to 97 to 98% accurate.
One more question is.
And radon test he has asked. I think there was no test actually. We just deploy the detectors. We don't conduct any tests. We deploy detectors, and it depends upon the choice of the measurement. Means we want to detect in air, then pinhole cup dosimeter is the best detector which you could deploy. For short-term measurements, RAD 7 is an instrument which is very good enough. You could always use it. There is one question: what is the scope after PhD in radiation physics? There is a lot of scope after doing PhD in radiation physics. Most of my students are working in very good areas. Though in India, people are not so much aware about the radiations. They don't have an idea that once we go for a diagnostic, we should ask the doctor that how much dose have been given to me. But in European countries, in USA, the people are very much aware. But still in India, there is a lot of scope. No need to worry about it. So I think these were the only questions, sir, in the chat box. ठीक है सर, गुरप्रीत सर.
There is one information that we are shortly giving you the feedback form so that the certificates of participation will be sent to you.
Due to the actually time limit, we can even give them idea that how to conduct this or how to deploy this detector. I have not given them the idea that how to deploy and how to calculate, because that is a little bit bulky for them. As if you are not working in this area, calculation part you could always show them, but that will be little bit a bulky value for all those participants of this webinar. But just for the information sake, I have told them that these are the detectors, and 1 or 2 detectors I have shown them. Otherwise, I have kept my talk to a very brief. What is the radiation? Why we should measure it?
Yes.
So there is an information for our students and participants that feedback form has been shared with you in the chat box. You can fill this feedback form and can get the certificate of participation. Any other
Actually,
from the participants they can ask now?
Dr. Gurpreet, may I
Yes,
say
yes,
something?
yes, yes.
Thank you, Dr. Rohit Mehra, for this very interesting talk. And I must say that what is our actually aim is to organize such type of event that student should be motivated to take the science as their research career.
Definitely.
Another thing, the main objective of the DBT Star College is the same. And I feel from today's talk that is very interesting because whenever students they learn about science exactly in their neighboring environment, they are much more feel it that science is actually there. Otherwise, they are having the bookish knowledge or they are studying this and that. But now, from today's talk, I must say that students they are motivated. They will visit to your lab so that they can have the exact idea how the dosimeters they are installed, how you take that cellulose nitrate film, and how you calculate the radiation from those in your labs. So I must say that Dr. Gurpreet will organize this visit to NIT Jalandhar and take it as a research project that can be done. You can have different type of soil or water samples. Dr. Vikas is already has done this, and you have guided him, and we can do it for the students also. Thank you, sir, for sparing your valuable time for our students.
Thank you.
Thank you. Always will be a
Thank you.
pleasure with you.
Thank you very much, sir. Now, for formal vote of thanks, I now request Dr. Buggal to give the vote of thanks to Dr. Rohit.
Thank you, Gurpreet sir. Good afternoon, everyone. It's my privilege to have been asked to propose a vote of thanks on today's occasion. I, on the behalf of DAV College Managing Committee, New Delhi, and Department of Physics, DAV College, Bathinda, extend a hearty vote of thanks to our most valued invited guest, Dr. Rohit Mehra ji. Sir, thank you very much for motivating our students. Thank you.
Thank you, sir.
Thank you, sir. We are closing. फोन करके कर दूंगा